Welcome back. This is Kyle the Nostalgia File, and you should be watching this on the Kyle the Nostalgia File channel. Anyways, sorry about the poor video quality last time. For some reason I had the resolution turned down on the camera. So I figured before we get into the next step here, let me just give you a quick look of what we've got on the board so far. You can turn it on here and the tube should light up. Yeah, it's glowing. But that's about it. We get a little bit of hum if you touch the coupling capacitor. Not a lot at this point, but okay, yeah, we have some plate current coming up yet. But I don't think I have the... No, I don't have it hooked up, so I'm not sure what that's all about. It might be that crappy filter, I don't know. But let me get this thing mounted here so it's not so all over the place, and we'll get on to the next step here of putting this on the board. Alright, the next step that we're going to do with this is get this number 75 tube mounted up on the board in the circuit. Now eventually I want to put some controls on this. A treble and possibly bass control, a volume control between the driver and the output tube. I'm thinking of doing a control in the front end of this amplifier. It may be after this tube or between these tubes if we end up needing this tube, or after or before this tube if we need it, or the other way around. I'm not sure about that yet. And I want to add a line output, or at least close to line output, so that if I have this plugged into a detector on either a homemade radio or on a pre-made radio, I do have the detector tapped on my 746 ICOM, and I do record sometimes stuff that I find out there. And while I do have a better amplifier than this for listening, could potentially use this if I didn't care so much about the audio quality and wanted something to give a little bit of a boost before going into a tape deck. So we're not going to go into putting the controls on the board at this point yet. We're just going to get this wired in, or into the circuit. And in the next part, I think we're going to get some more gear on the bench here and do some tests and see just how sensitive this little amplifier is. I decided to go with the cathode bias on this amp. I was going to go with the grid bias, but I didn't have any 10 mega ohm resistors, although this would end up being real close, or two 4.7 megs. But we're going to end up going with the cathode bias. It's not much less gain or voltage output versus the other method. We'll be able to keep our grid resistor going into the 42 here at the maximum of 500k. It actually calls for 510, but 10 kilo ohms shouldn't really throw things off too bad. And then we'll only need 100 kilo ohm for our grid resistor on the 75 versus a 10k or a 10 mega ohm resistor to grid leak bias it. And then we'll have a 5.6k ohm cathode resistor. They do call for a cathode bypass capacitor. I do have some of those. I think I'm going to try it without the capacitor first. Without the capacitor you have less gain. However, at the same time you also have less distortion. So a little bit higher fidelity, I guess you'd say, at the cost of gain. So we're going to try it without that capacitor first. And then if it don't work, then we may even go to as far as adding a third tube if necessary. But I'm going to get this wired up here. I need to put a couple 500K resistors in, the 5.6K cathode resistor and our 100K grid resistor. We'll use this coupling cap for now. I can't remember, it's a 0.015 microfarad. Probably a 0.22 would be a better option. I'll have to look. I'm pretty sure I've got one. And then might do that if I can find two of those, or a 0.1 possibly, and put that right here because we need a coupling cap into the grid of the tube here, especially if we're going to put another tube ahead of it. But we'll see how that goes. So we're going to turn this off for now, and we're going to get this on the board set up. And when it's set up, we'll come back and we'll see what she does. Alright, well, we got it in there. Kind of ugly situation for the cathode resistor for the time being. Didn't have quite the right value, but well, we'll probably find one, or if not, we can pretty this up a little bit and it'll end up being underneath the chassis where no one will be able to see it. We did change our coupling caps to, I believe they're 0.33s. Yeah, 0.33 microfarad. We have our grid resistor in there, plate load resistor, and our grid load resistor we changed for the power tube. And my clip just fell off for the ammeter. Had to go find my plate caps. Now on this tube it's actually not a plate cap, it's actually a grid cap, but still uses a regular plate cap. And fortunately I do have a jar of them laying around. So we have right now the green jumpers for our power tube, bring B positive to it directly instead of through the ammeter. Black leads the negative from my ammeter. This has got to get clipped back in there, it fell off. And we want to measure the plate current on this tube. It's only allowed to have a plate current of 0.5 milliamps, half a milliamp. So that means I'm going to put it down on the 1 milliamp scale. We'll still be reading the same 0 to 10 scale here. You just have to take any of your readings you have here and divide it by 10, and it'll come out to what you need. But for most practical purposes, you know what it is. Alright, well, I'll get her hooked up here, get this back on the tripod, and see what happens. Oh, and then we have the black lead, which is just connected to, should just be nothing, just do the old hum test on her, I guess. And we can clamp one onto our B negative here when I get that far. And at some point, probably in the next video, if everything looks good, we'll probably do a few tests on it and see what we have for gain here. So let me get this thing set up here, and we'll give her the old smoke test. Alrighty, we're ready for the smoke test. We have this on the 1 mil scale. Turn this to DC volts. Alright. Well, we got bulb illumination on one side. I can't see if we have bulb illumination on the 75. Oh, yeah, we got bulb illumination on the 75 tube. Alright, let's start cranking the B positive up. Not really liking what I see for plate current here. We're already almost at half a milliamp. Let me just double check to make sure that's right. That almost seems kind of light. But I guess it's possible that it's that low. Oh. Plate dissipation, half a watt. Plate current. Okay, my bad. At 250 volts, it's going to be just over a milliamp. So, as long as we don't peg the meter, we should be okay. It's going to be awful close. We're at 0.9 mils, 230 volts. Oh boy, we got, whoa, yahoo, that felt great. We got smoke. That felt good. Fortunately, I've got this on a power strip down below, so I can isolate the whole circuit. Yeah, that felt good. I wasn't expecting that. Alright, let's disconnect the variable voltage supply and see what smoked. Okay, supply's disconnected. And we definitely had some smoke being emitted here. What in the world blew up? Something smoked. Don't appear to be our bleeder resistor. I wonder if it's a filter capacitor failed. Or, alright, well, let me take a little closer look into this thing and see exactly what happened. I don't know if that ever showed up on the camera, but I don't know, definitely some smoke came out and you got to see me zap, so or get zapped, so hope we got a good laugh there. Alright, I think I found what went smoky. Forgot we had, looks like it was probably a 100 ohm resistor, maybe 10 ohm. Sometimes the colors change on these when they burn. And obviously it didn't like the load I was putting on it. I almost forgot to put that in there. But the show can go on. We can just switch to the section that has less filtering on it. We might have some hum as a result, but should take the load off of that resistor and hopefully keep this thing from letting out more smoke. And I guess lesson B from this is don't be a dummy like me. Build your stuff in an enclosed case. Although I don't know if it has to do with anything with that crappy power switch or if there was actually a ground fault or something. I don't know. But take it from me, don't be a dummy. And be careful. Especially when you're working on open circuit junk like this thing. Anyways, we'll plug her back in and give her a shot. Alright, we're going to try this again and see if we get any more magic smoke. Hopefully not. We have that pretty much out of circuit. I don't know why that popped. Try this again. Slowly bring our voltage up. Okay, that's really weird. What happened there? Why does our circuit breaker keep popping on the meter? And it appears the ammeter might have died in my variable power supply. Something definitely popped because it appears the voltmeter is no longer functional either. But we still have voltage available, but we don't have any heater voltage going on. So what in the world happened here? Did we lose the heater transformer? I find that hard to believe, as that's the damper diodes in my supplier ran from the same transformer, and them were illuminated. So now I guess I got to see what happened to my heater circuit here, why we don't have any heater voltage. Stand by. Alright, that was a simple fix. It was just a matter of a terminal that popped loose in the on one of my screw terminals in the power supply. So that's a straightforward fix. Alright, we have definitely a lot more hum. Lot more hum with that filter removed. Alright, well, a couple ways to remedy that. I guess we can temporarily stick a bigger capacitor on. Not what I'd normally recommend doing, but the fact that we're bringing the power up slow, we should be alright and not damage the rectifier tubes. So let me go see if I can find a cap. Alright, this is starting to look more like a project video more and more. We have things that crap out all of a sudden. You gotta come up with some wild things to be able to make it work. We have a multi-section electrolytic here. Hopefully it's good. We're using a 20 microfarad section. We're going to see what happens. We may get more smoke. Whoops. Okay. Bulbs are illuminating. That made a difference. Before it had a horrible hum with only about 30 some volts on it. Now we're actually halfway to where we need to be. Let's switch back now. I don't know why it keeps doing that crap. Okay. For some reason the hum test isn't working on our tube here, so I'm not sure what that's all about. We're okay for our plate current on the 75. We're a little over 0.9 milliamps at about 245, so we should be okay. Not sure why we're not getting any hum from the tube though. Is our tube dead? We're pulling current, so we know we're connected. Alright, I guess I need to look at that once and see what's happening. Alright, well, I messed around with it for a while and I figured out the problem. Real stupid mistake on my end. There again, probably shouldn't learn nothing from me, as it might be a little misleading. It kind of works now, but we gotta straighten it up. This isn't quite enough capacitance to filter it out properly, and well, all these stupid things hanging around don't help it any. So we gotta clean it up a little bit to get her working properly. But we do have gain off this tube now, and we have less plate current. I'll show you what I did wrong. There's a nice little schematic here. We have our 100 kilo ohm there for our grid leak capacitor. Our 5.6 down there for our cathode capacitor. We have our grid resistor for following stage, 500 kilo ohm. We have a 500 kilo ohm plate load resistor for our number 75. Well, without that plate load resistor, no voltage in terms of AC voltage will be generated on the tube, or the plate of the tube. So you need this resistor in line, enable or for this tube to actually have something to develop AC voltage over a load, I guess you'd say, to drive the next stage. Well, I, in my stupidity, read the schematic wrong. If you look very carefully and you go down, the other side of this resistor is supposed to go to B positive, not ground. This one goes to ground. The one after the coupling capacitor is this resistor for the next tube. So I had this grounded, and what threw me off is with the jumper, it worked. Problem was that I ohmed out the jumper. It was a bad jumper, so the jumper itself was acting as the load resistor. Imagine that. So I disconnected this from ground and put it to be positive where it's supposed to go, and it actually works. Now we do need to do some work on it, but see if we can turn the ICO around here, playing Jenga with our test equipment. Ooh, that sounds nasty. On the grid, about 4 volts. Going to the grid of our output tube, about 5.5. Should go all the way up to 15 with 5 on the input stage. I'm going to turn that noisy bugger off. So my conclusion is we're going to need this other tube. And I think we're going to put it, I don't know if I want to put it after the 75. This isn't going to give us a ton of gain, but we'll take what this has here for gain and amplify it more before we put it into our power stage. Or if I want to put this ahead of the 75 to give a nice little boost to drive this, so we can get the maximum potential that we can get out of this tube. So I think first things first, we need to get all these stupid jumper wires out of here and actually get this thing kind of semi-permanently wired together, and then experiment with where we want to put this tube. But I think before that, benchmark it again, maybe even get the scope out and do the same thing here over again, but with this noisy, grabbing, crappy capacitor junk out of here. So, hope you didn't get too bored. I guess you got to see me be a little bit of an idiot. I guess biggest thing to learn, be very careful with this crap. High voltage, always one hand, never both. You get hit in one hand, if you're standing up, power's got to go down your leg. That's more resistance, and it's not going across your chest. It's going to hurt, but your odds of surviving is better where both hands goes across your chest, less resistance, and you might die. So remember that rule. Put your stuff in enclosures, unlike me, which that's kind of a dummy move on my part. And that's about all we have. And look the simple crap over before you decide to really dig into it there. And sometimes even the best make a stupid mistake like I did with this. Anyways, thanks for watching. Tune in next time.